2, 3. Welcome to the Hudson Junior High School Physics Lab
for a demonstration of Isaac Newton's third law of motion. Our science teacher is using a simple methanol-powered action-reaction cable car to help physics students to understand the third law of paired forces as it relates to self-propelled vehicles. Rockets, jets, CO2 racers, jet skis, and jet packs are all self-propelled motion devices that use the principle of action-reaction forces to push or propel themselves and their passengers forward. These vehicles all have one feature in common. They expel high-speed exhaust gases or high-speed water streams that provide the forces necessary for self-propulsion. Action-reaction systems are the only type of transportation technology that can move through a complete vacuum. It was the invention of rocket technology that enabled humans to move vehicles through the emptiness of interstellar space, exploring the mysteries of our solar system and beyond.
In this demonstration, the interior of the empty 2-liter bottle is coated with a thin film of liquid methanol. Methanol is a flammable hydrocarbon fuel that is commonly used as a gasoline additive. When the 2-liter bottle is sealed with the cap, the liquid methanol evaporates, filling it with a volatile mixture of methanol vapor and oxygen. When ignited, the rapid combustion of methanol vapor produces the super high-speed exhaust gases necessary for self-propulsion. In order to understand how action-reaction forces produce the motion of the methanol cable car, you must first be familiar with Newton's third law of motion.
The third law of motion states that forces always occur in pairs. These paired forces are always equal in strength but opposite in direction. It is these action and reaction force pairs that produce motion. When force pairs are exerted, the body that has the least inertia moves the most. For example, the tires of a school bus exert a rearward action force on the road. The road then exerts a reaction force that is equal in strength but opposite in direction. The road and earth have too much inertia to be moved by the bus. However, the reaction force of the road easily pushes the bus forward because it has so little inertia compared to earth. When the oars of a rowboat push against lake water, the lake water pushes back with a force that is equal in strength but opposite in direction. The rowboat has much less inertia than the lake water, so the water's reaction force easily pushes the rowboat forward across the lake's surface.
Action-reaction vehicles do not need a roadway or lake water to provide the secondary reaction force to push them forward. The high-speed exhaust gases that a rocket pushes out push back on the rocket, propelling it forward. So action-reaction vehicles like this methanol cable car can literally push themselves forward, hence the term self-propulsion.
We hope you enjoyed this demonstration of Newton's third law of action-reaction forces.
And remember, do not try this at home, as you would risk serious injury to yourself or others.
Thank you for being curious enough to watch, listen, and learn.